Good morning, good afternoon, good evening. Welcome from wherever you are in the world today. Welcome to today's session, Redefining Patient-Specific 3D Design. Today I'm joined by Joel from one of our Geomagic partners in America, Cimquest, and Dave, one of our Octon Freeform gurus internally. And today they're going to be giving you an overview and a demonstration of Octon Freeform, and as the title suggests, how this tool can be used to help you redefine your patient-specific 3D design workflows. Just a few housekeeping bits before we get started. We will have around 15 minutes at the end for question and answer session. Joel and Dave obviously are here. We're also joined by Kevin Atkins, the product manager for Freeform Octon. He will be jumping on right at the end to assist with any of the questions that you might have. Dave, if you could move over to the next slide. So a short agenda before I pass over to the presenters today. Both Joel and Dave are going to give a bit of an intro to themselves, who they are, why you should be listening. We're then going to jump right in and discuss why you're all here. We're going to look at some of the challenges associated with patient-specific instrumentation and patient-specific design, how Freeform addresses these challenges, and then we will jump into the software and take a look at two example workflows. One, the design of a CMF cutting guide, and the other, the design of a custom ankle-foot orthotics. As I said, the main bulk of today's session will be around 45 minutes, and then we will open up for questions for the last 15 minutes at the end. Joel, Dave, over to you.
Sounds great, Guy. Thank you so much. Hello, everybody. My name is Joel Paulette. And I've just a brief introduction for myself. I've been with Cimquest for about 10 years. I head up our scanning and scan processing technologies, including Freeform software, which is a product we're going to be featuring in today's presentation. Prior to Cimquest, I was the US General Manager for a Siemens partner for about 8 years. And then prior to that, it's really when I got heavily into scanning and scan processing. I spent several years making masks for burn victims, where I would scan their face, 3D print a mold, and then vacuum form a mask to apply pressure to the wound. So been in the scanning world for probably about two and a half decades. In the early and mid 1990s, I launched two very successful CAD/CAM reseller companies. And then going back into the late 70s is where I began my career as a manufacturing engineer at Grumman Aerospace. Then I took on a position as an engineering consultant for McDonnell Douglas. So just those were some of the highlights from my 43-year career in our industry. I'll now turn things over to Dave to get Dave DePinto, who'll tell you a bit more about his background, and Dave will be our main presenter today. So Dave, it's all you.
Thank you very much, Joel. As you can see, I'm David DePinto. I'm the current product owner for Freeform, so I am the person who works with product management and development. My history with Freeform goes back now about 13 plus years. I was a quality assurance tester and manager at Sensible Technologies back before the acquisitions. I have a background in 3D design as well as a bit more in the software development and software product world. So for me, I am not a medical professional. Please be kind to me. I'm going to do my best, but I've learned an awful lot over the years, and I hope to be able to show you the power and the majesty that is Geomagic Freeform. So without any further ado, we can get into this demonstration. I mean, not the demonstration, but we'll get into the webinar. The challenges for patient-specific instrumentation, it's on the rise. It's been proven to give better treatment than generic solutions. Designing devices in healthcare environment has a very unique and specialized requirements and challenges. How many of you have ever tried to do any type of medical modeling or modeling on organic data using traditional CAD software? You know that it has its limitations. You know that oftentimes it's fraught with peril. It can fail. It can give you endless amounts of frustration. Freeform, on the other hand, was designed to work with organic data. So unlike traditional CAD systems, Freeform was optimized to handle complex anatomical forms as well as give you the ability to work with CAD data. So if you need a system that can efficiently handle patient data without any added complexity, Freeform is what you are looking for. The combination of freeform surfaces and engineering control is the holy grail for what we are looking for. Healthcare devices aren't typically completely freeform. They do have mechanical components. They have external parts that you will receive from manufacturers. Trying to combine these together with patient-specific parts is a big challenge. So integrating organic with data, with hard surfaces, with imported materials, you are going to need a unique tool in order to accommodate that. Dimensional control is also something that is required for this field. You need to be able to create something that is a known thickness or a known size, and that is to provide strength, that is to provide control over the part that you're going to create. So it's more than just making sure a screw fits in a hole, but strength. Sometimes manufacturing processes have certain requirements. Freeform gives you the ability to have this type of control while still respecting and working with the anatomical data. There's an added element that for repeated workflows, Freeform does offer some additional control that is useful when it comes to regulatory compliance. Speaking of which, the type of workflows that Freeform is capable of processing is limitless. If you've used systems such as automated systems, you will have encountered times where edge cases or challenging geometry just do not work. Freeform allows you to handle 100% of these cases. So there's automation built into Freeform. You can work on specific parts of it. You can automate parts of your workflow, but there's going to be times where you need to use manual intervention in order to achieve your goal, in order to finish your project. And Freeform is one of the only solutions that supports both of those. So you have the flexibility to handle very challenging cases with the automation and assistance to take care of a lot of the day-to-day work. Automation also allows you to remove some of the potential human error in repetitive designs and situations where you're doing things that are frequently done. You don't have to worry about it. We have seen times where small human errors that go noticed, like a labeling error. You read something off of a patient sheet, you put one wrong letter or one wrong number, send it down through your pipeline to be manufactured. It doesn't get noticed till after the part has actually been produced. The quality system picks it up, and that triggers an entire rebuild. Something like that is catastrophic. So having some automated assistance will allow you to hopefully avoid some of those cases. So why Freeform? Obviously, there are challenges and requirements in the healthcare space, and Freeform is one of the best solutions that I've ever encountered. Efficient and effective patient-specific instrumentation design. So while traditional CAD systems are great for mechanical parts and the work and the use cases they are traditionally known for, this is not their strong point. We've had customers who have tried many solutions. We've had them report that sometimes they have difficulty with it, and sometimes they can't even achieve what they're looking to do. Freeform removes some of that, and we have actually had a customer once upon a time who requested a demo, and they gave us 3 cases to do. We were able to complete the 3 cases in an afternoon, deliver them the parts, show them the parts, and they were happy with it. And later they reported back to us that the first case would have taken them a day to do in their system. The second case traditionally took about a week to do in their system, and the third case was impossible. So Freeform not only removed barriers, but it showed an incredible amount of efficiency. Second point of why Freeform is our comprehensive tool set. So for maximum productivity and workflow flexibility, you are not going to beat Freeform. It's backed up by a manual tool set that has been used in the medical industry for years. This allows for cases that are challenging. This is wonderful at handling the things that oftentimes are almost thought to be impossible to do with software. We did have a surgeon who was trying to create who was actually using an automated solution for one of their projects. It failed repeatedly. They tried several times, and luckily they had a not a co-worker, but someone that they knew who had Freeform, and he asked them if he could actually take a look at the job in Freeform, and he turned it around in very short time. So it's not unheard of that going to Freeform is the right choice and a great solution. Your product lifecycle can live within Freeform depending on where you are in your design, and there's no reason to ever leave Freeform. So it supports you throughout the entire lifecycle. When you're concepting, you require a solution that's flexible, easy, no restrictions, and you can make your concept with absolute freedom. Once your design is set, you can then introduce it to market. Freeform supports you there by allowing you to create guided workflows to help with compliance, progressive automation to help you build up automation to make your process more efficient, and eventually evolve into larger workflows. And as you achieve success, you can scale for mass customization, and you don't have to leave the software you're comfortable with. Freeform grows with you, and it is a wonderful tool, and it's actually a pleasure to use, which is helpful for having a happy staff. In terms of workflow integration, the parts that you create have to be manufactured. So Freeform was designed from the beginning to actually create the parts that you design. That is part of the core concept, and it is agnostic. So if you need to go to CAD, if you're going out to additive manufacturing, if you're doing subtractive like milling, a hybrid approach for additive followed by subtractive, your design will be able to be manufactured, and there's no limit on what comes into Freeform either. We accept data from all types of scanners. You can import CAD data. You can import medical DICOM imaging into Freeform, and we work with all of it. The last point to highlight is the minimal learning curve for Freeform. So unlike a lot of CAD systems where there's a lot of abstractions, there's a lot of time spent thinking about how to model, Freeform lets you get on with the job and just model. So it applies physical craft style working methodology to working in a digital space. It not only enables a minimal learning curve, but they also make you more productive once you're fully trained. I have to do this. This is part of my job. So for the sake of just taking a moment, regulatory compliance, many medical device companies are successfully using Freeform in compliance with regulatory requirements. Freeform itself is not a medical device, and we don't claim that it's intended for medical treatment, planning, or diagnosis, but it can be integrated as in a validated workflow as off-the-shelf software. So if you're going to be doing a regulated work, if you're going to be doing anything with regulation, Freeform will work for you. Without getting into the details, as long as it's validated as off-the-shelf software, that's how many of the world's leading medical device companies are using Freeform with full compliance. We might not be regulatory experts, but if you have any questions, please feel free to reach out and we can point you in the right direction. I just will quickly talk about the benefits across some of the specialties of Freeform. So we've already mentioned CMF. This is where the patient-specific world began for Freeform. It's currently used by two of the three largest organizations in this specialty. We've been using for orthopedics as long as CMF. The example here is a revision case where there's so much bone loss that a standard implant no longer worked, so it required special instrumentation, and Freeform handles the job spectacularly. Extremities, here we have a generic implant, but the guides are made for the surgery, and that allows for greater efficiency and accuracy and ultimately better patient outcome. O&P is a market where we're having a lot of success because O&P specialists really take to the unique user experience and the haptic interaction, which allow traditional craftspeople to translate techniques used in the physical space to the digital design space. And honestly, if you're used to working in the hand-built, bespoke world, wouldn't you like to have an undo button for creating an object? Anatomical models, there's an art to creating anatomical design models. Segmentation is just a small part of the puzzle. Artfully coloring, creating supports, connection structures, often required, which, when done correctly, blends seamlessly, but it is something that needs to be considered, and Freeform is a fantastic tool for this job. Finally, radiotherapy. This is a rapidly growing section where very close fitting devices are required to deliver treatment to a defined area. Freeform is ideal for this based off of scanned patient data and the ability to create the designs very quickly and effectively. So this is just an overview. This is by no means a complete list of the areas that were being used, and this is, yeah. The two workflows we're going to talk about today are CMF guides and ankle-foot orthotics. I wouldn't be able to do this without talking about the hardware. So of course we have the touch haptic device, which is the input for Freeform. This allows me a lot of creative control as well as some very unique ways of interacting. And of course, part of how we get data into Freeform is using objects like scanners. That is a structured light scanner. It's one of many manufacturers that we support. You can export the data, bring it right into Freeform, and use that as the basis for your design. Now I'm going to jump straight into the CMF guide. But first, I will also turn on my webcam so you can see the haptic device in action. So we have a surgical case. This is a CMF case. It's a fibula flap my goodness, I can't remember the name of the actual procedure. I know that this here is a resection of part of the maxilla, and the workflow that I'm going to show is how to create the surgical cutting guide that will rest on top of the maxilla in order to resect and remove part of the bone. So I will begin by hiding the completed parts as well as the skull and the fibula. I'm going to work on the posterior side first, so I can hide that. And the first thing we need to do is define a cutting plane. So I will touch my surface and align a plane using just a couple points I click and select. You can see that that is perfectly aligned with the cut. And now grab and rotate. So now it is facing outward. Look down along the surface of the bone and pull this off the surface because I'm going to create sketches in order to define the region of the guide. Turn back on the pre-op mandible and hide the resection really quickly. So the first thing we need to do is create, actually I will go back to the resected view because we want to see the bone. Create a cutting slot. So the actual region where the saw blade is going to go. I'll start above and go down below, giving clearance on either side, and pick my width of 1.5 millimeters. And then I will offset this in order to create the plastic or the material that's going to be around this, automatically round the corners, and offset that to the outside. Actually, I want to do that at 3 millimeters. Make it just a little bit stronger. And from this view here, now I want to turn on the pre-op so I can see the mandible, look back at my sketch, and just define a curve that is going to avoid the tumor. So when the guide is placed down, it does not touch that. And now create just a small line across the remus. So start here, go straight across the back. This does not have to be straight. This can actually be any shape you like. It's entirely up to the designer. And connect these together. Now I can leave my sketch because from here, I'm going to create the body for the guide. So offset the mandible, going to do this at 2 millimeters. This provides the surface for where the guide's going to be. Smooth this. And use my wire cut tool to trim away everything that I don't want. This leaves me with just this region here. I can go into my selection tool and select that piece of clay, get rid of everything else. Turn back on the mandible so you can see how that sits. And now I'm going to create the cutting slot. So the entire slot region is going to be created using the wire cut tool as well. Create this as a brand new piece. So now that we've got both of those, we have most of the geometry we need in order to create the base structure of the guide. I will rename this piece to guide and call this slot. And just for the moment, I'm going to hide the slot. And we're going to look from the superior view and trim the surface of this guide so we can define an area of wrap. This is entirely based on the preference of the surgeon or your preference as a designer. So I can see the ridge right here. Go into my selection tool. Want to make sure I have enough coverage. And if I rotate from the side, you can see that I've made my selection from one perspective, but I can determine with the haptic device how much I want to capture. Pick that much, press delete, and you can see that it's a tiny bit shallow for wrap on the superior side, but that's my fault as a designer. That is not a fault of the software. I'm going to do the same from the inferior side. So looking from here, make some selections, and now delete. Not to worry about anything that wasn't captured. That will be picked up when we separate out the bone from the guide. That looks good for right now, so I will turn on the slot, activate that, and do a similar matching cut to trim off the rear side of the slot. And while I'm here, I'm going to look down the direction of the exterior surface of the guide, and I'm going to trim off a little bit from the slot because it's a little thick down here. Actually, that looks pretty good, but I can trim a little bit. So if I make a cut like this, that will do. So now I can combine this into the guide very easily. I don't have to worry about geometry. I don't have to worry about thinking of anything. All I have to do is say these two objects are intersecting each other. I want to combine them. Click to combine. That time I accidentally picked remove. So Boolean, combine into, pick my guide. And now we have this object, which I can apply a little bit of smoothing. I will reduce that level to get an overall smooth, and I can manually smooth the region between the slot and the base of the guide. So if I use this, I can very quickly go through here and now I will increase the resolution of this object by just changing the coarseness. It will resample that surface. And remove the pre-op mandible. So now I'm going to remove that from the guide. We still have a little bit of floating information on the back, which I can very quickly delete and turn back on my original sketch. I'm not sure what happened. I seem to have lost my haptic device. I think I bumped my, I may have bumped the hub that I have. So for the moment, just to finish this, I will do this with my mouse and then I will reconnect my device, which will only just take a moment. But I can trim this, select that slot, turn off create a new, and remove that out. So I'm going to save this as demo temp, because there's still one more thing I want to show in this demonstration, but I need to leave Freeform in order to do it. The wonder of live demonstration. So I just reconnected and calibrated my device, and now I will launch Freeform once again. And I'm off to the races. So from here, I wanted to add a K-wire boss, so I can click and drag from outside, import this. Oh, nope. I picked the wrong button because I chose to open that file instead of import. So going to choose. Wait, no, okay, that's my fault again. There we go. So this here is an object that I've already created inside Freeform. It has the sleeve as well as the removal for the wire. With both of these selected, I can reposition these manually using my haptic device. So I will choose my reposition piece tool, and very quickly, if I turn off my guides, I can rotate this around, move this into place, and with the 6 degrees of freedom and the ability to line things up, see it, I can place this and do that manually. And that is a fantastic workflow because it's very similar to what you would do if you were actually creating a guide. Now is an opportunity to show some of the automation that we have. So if I turn back on my mandible, I am going to place a couple axis markers, which are just 3D curves that sit perpendicular to the surface. So I'm going to touch the surface of the mandible. If I hide my guide, actually, I'll keep the guide up, touch, and I'll add 3 of them. So with those 3 in place, I can use our Dynabot automation system in order to generate the K-wire guide and align to each of those places. So I'll put down my haptic device. You can see that I'm not going to touch it. I have a Dynabot pre-created right here. So click that once. It gives me an instruction of select the axis markers. So I select those and click play. Now I have an interface that lets me choose what I want for my my piece. So I'll just do 2 millimeters and I'll click continue. And now I let the computer do the driving. So it's going to create the object, and then it's going to select it and manually pattern it, create it, and clean itself up. So now I didn't have to do any of that work. All I had to do is feed in a couple parameters and we are done. So there's an awful lot of power with a little bit of effort of doing some of that work ahead of time for automation. That being said, the only other thing to a guide, oftentimes we will add perforations, but I'm not going to do that here. I'm going to move to the next demonstration, which is our Ankle-Foot Orthotic. So we have a scan of a leg as well as a rough orthotic that was already created. I will hide these and begin from the actual scan data. And if we look at this, we can see the foot is not in an ideal position. So to remedy that, if I rotate and look at the front, I can use my bend and twist tool. pick where I want the bend to begin, right on the ankle. Define the region where the actual bend is going to happen. So it will happen within there, and then everything below will be affected. Start my bend and turn on view lock. So I'm only going to be able to bend or twist in the direction from my view. So I can click this handle and hold shift to get finer control and straighten out that foot. I will remind everyone once again, I am not a professional I am not a medical professional, so I am making my best guesses here, and I'm simply showing the tools how these can be used and applied. But as you can see, if you knew what you were doing, this should be very easy to do. That looks pretty natural to me, so I'll click apply, and there we go. We have that. So now I will select this and copy it to clay. Now that we have our clay representation of this model, I will clean it up a little bit because there were some small imperfections from the scan as well as an attachment point. So start by removing this. I can just make a selection around there, feather the selection, and defeature it. And that removes that pretty well. I can manually go through and remove blemishes with my smooth tool. I can clean up certain things, and I can also roughly apply an overall smoothing to it, especially because in this type of case, we're going to be building something that's sitting on the surface, and this here was an external scan, so it doesn't have to be precise to 1/100th of a millimeter. Removing a tiny bit of surface texture is not going to hurt. In order to create the region for the orthotic, I will start with my pencil and create a 3D curve that is on the surface. So I can simply touch to add points, and for every click, this is going to fit a curve onto the surface. And using my stylus as well to rotate my view. I don't have to worry about special hotkeys. I don't have to worry about not being able to see exactly what I'm looking at. It's very intuitive and natural to rotate, continue working from a specific view. And I accidentally clicked through and it snapped and I lost my curve. There's nothing quite like live demonstration. So very quickly, start this again. Just go under the ball of the foot. Connect that up, and there we go. To create the offset from this, I will begin first by duplicating my piece, and I will call this just AFO, and I will emboss this. So pick my tool, grab my curve, set my distance. 3 millimeters is actually what I wanted, and raise it off the surface. So from right there, we have already created an object that is based off of this patient data. I can hide my original curve, and it would be very easy from here to simply remove the original from this part here and just keep this. But Freeform offers so many additional tools. Let's say, for example, I wanted to create a bit of structural support up along the back edge here. I can use my 3D curve tool. Just add a curve that goes up the center here And if I want to apply something like a ridge to create a flat spine, just have that go along there. I'll create this as a new piece. That'll give me the ability to modify it independently. So for instance, if I want to make the bottom smoother and intersect, I can use my tug tool. And this allows me interactively, I can click and shape that in. The same up here at the top. Now with that in there and applied, I can combine into my AFO. And I will do this at the finer clay. Another thing that we can do from here is if I wanted to do something like, actually, I will create the curve regions to add perforation and breathing areas. So I'll just lay a couple curves that are fit on the surface. Define where I want these to go. I'll do one on either side. And now I will remove the original. So I've got the positive offset, actually, yes, the positive offset. So Boolean remove from AFO. Nope, that was the wrong object. Yeah, the lower leg is the one I'm choosing. So remove from AFO. And I see that my curves are not very well aligned with each other. So I can edit these really quickly before I add the detail. Using my pattern piece, select that, choose the region I want this to happen, and go to my library, pick a pattern, and interactively I can scale, rotate, reposition and align, as well as set the depth. I want this to go all the way through. And that will generate a cut pattern just using a simple 2D image. Automatically uses the same values from the other side, so I don't even have to make a change there. And if I want to, I can bring in a strap. So this was an object I had created separately. This here will just act as a fixation point for a strap. I will reposition this, and we can call this design complete. So I just choose my reposition piece tool, turn off my constraints, grab this, move this up, and as long as this intersects with the part, Boolean, combine into, very easy. So this is where I will end the demonstration. So we still have time for question and answer here at the end.
Hey, thank you so much. That was an awesome job. Those of you that have worked with or work with mechanical CAD products, hopefully you can see the little bit of overlap between freeform and traditional CAD modeling, where you have planes, sketches, extrusions, revolves, and so forth. I just want to give you about a 1-minute overview of Cimquest, and then I'm going to turn things back over to Guy to organize our Q&A session. So real quickly, Cimquest is headquartered in Branchburg, New Jersey, with offices in the Mid-Atlantic and New England states. We have about 60 employees. We've been in business for over 33 years, support many manufacturing disciplines, including additive and subtractive technologies, both of which are the key components of the manufacturing ecosystem. We offer pre and post sale support, technical demonstrations, training, consulting services. We have a team of seasoned experts for all of the products and technologies we represent, certainly including the Freeform product that you just saw. We're one of the largest Octane resellers actually in the Americas. We represent all of their Geomagic software products for organic modeling, DICOM to mesh conversion, reverse engineering, inspection, as well as mesh repair. We also represent 9 3D printer brands covering 9 different printing technologies, including printers that support biocompatible materials. Cimquest is the #1 global reseller for the exact metal printers and is also the #2 reseller globally for Mastercam CNC programming software. So we will reach out to everybody who attended today's webinar to ensure it offered valuable information. But for now, I'm going to go ahead and pass things back over to Guy for questions and answers. Go ahead, Guy.
Thank you, guys. Really interesting. I always love to watch Freeform webinars. It's great to see how easily Dave can use that haptic device, even though there are the hiccups associated with live demonstrations. We have some questions here. If you've got any other questions, we've got 13 minutes, so feel free to drop them in and we'll get through as many as we can. If we don't get to your questions, then we'll follow up afterwards to make sure that you get the information that you need. So this first one here, I think was kind of answered by Dave already, but can Freeform work without the haptic device?
It can work without the haptic device, but not all of the tools are available, and the tools are designed specifically to work with the haptic device, so the experience is far better with the device.
Great. Going back to our slide on regulatory requirements and regulatory processes, how can Freeform assist me with FDA submission?
So depending on the workflow that you create, Freeform has the ability to hide and expose various tools that you have, so you can limit the tools that you would need to validate. Using Dynabots, you can create custom workflows or specific tools that for your workflow that are easy to document, and because they're automated and repeatable, it makes it much more attractive and easier to say that this here is the work order instructions that you're following. So when you're dealing with off-the-shelf software, you have to basically provide inputs and outputs. So if the tools that you're using Freeform are well documented, you can show a proper workflow, it becomes a lot easier.
Great. We've got a few questions here around Dynabots. Is there any documentation or forums or resources available for people wanting to pick up and create their own?
We are working on materials. There is a Dynabot user manual that ships with Freeform, as well as a lot of example Dynabots that come with Freeform. Those are all inside the install directory. We offer a Freeform training course that is something that can be done independently, but unfortunately there's no forums and there's no other materials available at the moment.
Great. There's a few questions here around DICOM import. I think it's more of an open question. Can you talk a bit more about the DICOM import? I saw a question here around the picture-in-picture in Freeform of using and working with DICOM data as well.
Absolutely. Freeform's DICOM import is somewhat limited, especially compared to other tools commercially available, including D2P, but we can view the slice data, we can make selections, we can do some very basic geometry extraction, but it really was not designed to replace a dedicated medical DICOM tool. It was created for a general purpose viewing of that type of data. So there's industrial CT machines as well as all of the variety of medical imaging sources. So we did not cater it to one or the other.
It
Yeah.
may be a good idea just to give a quick overview of D2P, if you have a second.
I honestly think that might be better for, actually, I don't see Kevin available. I can't answer to, oh, you are available. If you can speak to D2P for a moment, that would be fantastic.
Yeah, just briefly.
So, very quickly, D2P DICOM to print is all about importing a DICOM file, medical grade DICOM, CT, CBCT, MRI, and then giving you the tool set to segment the required structure you want into a mesh file and exporting them for 3D printing, for further design work, for planning purposes. It's got a complete tool set for doing that, very comprehensive. Plus, it's also got some very unique things to speed up segmentation of bone, vasculature, for example. And then it also goes into deep learning. So we've got some deep learning solutions for, especially for CMF at the moment, and then spine and a few other things as well. But you can just generally think of it as a very professional grade. It is a cleared medical product, for example. It does have a 510K and CE mark around it, but it's a very comprehensive segmentation tool set aimed at medical for medical grade DICOM. Works very nicely with Freeform. It's got an automatic export import into Freeform as well. But if anyone wants more information or demonstration, don't hesitate to reach out and we'll just get that arranged with no problem.
Great, thank you, Kevin. There's a few questions here around the overlaying of the 2D slices onto the 3D model within Freeform for validation. Is that something that is possible? Is that a workflow that we support?
We can, to some degree, overlay the 2D slices. When you generate the model, it can capture the color information from the slices, so you will see that. Inside the viewer itself, you can see an outline preview of your mesh or your clay in regards to the image stack. But there's not a lot of tools specifically around things like measurement or anything that I think might be better suited for quality.
But we can export the data and then import it into D2P, for example, and then you can do the analysis in your original segmentation software.
Right.
But if you're just looking for a visual, how does this device line up over the top of a bone profile, then yeah, we can certainly do that in Freeform today.
There's a number of questions here about the clay model. I think they're best summarized as, can you explain the difference between the mesh data and the clay model within Freeform?
Yep, very quickly, our clay is a voxel representation, so it's a closed surface. It is converted and sampled at the resolution that you define. So during the workflow, I changed resolutions a couple of times. It resamples your surface, and that gives you the ability to basically see that you have a fully closed watertight model. The voxel tools work with our sculpting tools, so that's one of the reasons why we separate the two representations in Freeform. When you're carving and many of our pattern generation or things or tools in that nature will work only on clay. because under the surface we're doing volumetric calculations, we're doing a lot of other things that rely on that data, but the ultimate result is going to be a mesh surface. So what gets rendered on screen is the result of a mesh that is basically wrapped around the volumetric data, which is what gets exported to when you go to any other downstream processes. So if you want to export, you're not going to be exporting the volumetric data. You are going to be exporting a mesh surface that is the representation of that volume.
And if anyone has questions about the accuracy converting, mesh to voxels, part of the cleverness here, the trick, even though we're using, for example, a voxel coarseness of 0.5 millimeters, we actually subsample under that to a 60th. So it's approximately a 60th. So you may have seen Dave type in 0.5 as your clay coarseness, but the actual accuracy is then a 60th of that. So it's like 8 microns, which is way below what you're ever going to 3D print, for example. So there's absolutely no problem with mesh to voxel conversion and back again on accuracy. The other benefit of voxels over mesh is like Dave mentioned, voxels are watertight by their very, very nature. So if you've ever done any mesh modeling and you get into having to recalculate the mesh to get rid of non-manifold surfaces or surface intersections, none of that happens with voxels. They all just magically work. And that's part of the benefit of working with Freeform. All those jumping through fiery hoops you need to do with abstractions, edges, polygons, intersections, non-manifold surfaces, you just don't do any of that on Freeform. You just go ahead and model.
Great. We've got 3 minutes left, so I'll field a couple more questions. As I said, I can see lots and lots of questions coming in, so I'll make sure that we reach out to anyone that has a question. Make sure that you get the answers that you're looking for. Dave, you mentioned earlier in the presentation that many large healthcare companies are already using Freeform. Are there any that we can name and shame, if you like?
I don't know off the top of my head who we have agreements with to actually specify. Kevin is also being a little smiley, so I didn't.
Yeah, unfortunately, a lot of our users just don't like us talking about the tools they're using to do their workflows. They view it very much as a competitive advantage over their competitors, even though then it turns out the competitors are also using Freeform. But what we can say is one of the world's biggest service providers for surgical planning, which is the 3D Systems Healthcare Services Group, completely independent from Octon. They use Freeform. They're doing in excess of, I think it's as many as 15,000 patient-specific cases a year now for a combination, mainly CMF, but also orthopedic extremities. And their workflow is 100%. If you took out Freeform, it would be a tough workflow to be as efficient and quick as it is today.
Great. We do have the customers that have agreed to share their use cases. We have a number of case studies on the website, so if you want to learn more around not so much the blow by blow of how they're using the software, but what they are creating and how they are using Freeform in their workflows, then absolutely head over to the website. We'll make sure to include some reference information when we share the recording with you afterwards. I don't think we have time for any more questions. There is a nice comment to end on. We have a user here that has just put in the chat that they've been using Freeform for almost 15 years and are very, very happy with it as a product. I want to ensure that.
Great to hear.
Yes.
Any questions? Any other questions that haven't been answered throughout this webinar? If you could put the next slide up on the screen, Dave. Joel is our main point of contact for these kinds of workflows at Cimquest. If you have any questions that relate to the webinar, relate to questions around workflows, any other questions that you think of after this presentation, feel free to reach out to Joel, head to the Cimquest website and take a look at what they do. As I said, we'll share with.
Can I jump in? I apologize. It's 223-6418. There's a typo in there, so I apologize. For the cell number, it's 610-223-6418. So I apologize. Go ahead. Yep.
No problem. We'll share the recording afterwards. Make sure that the team follow up with everyone that has questions answered, unanswered, to find out if they need any more information. I wanted to say thank you to the presenters. Thank you to everyone for joining. Really useful session, and we hope to see you in the next one.